I got a phone call from one of the experts in the field of AMR, AMI, one of the consultants in the field, and he wanted to know why the implementation of AMR, AMI in an electric cooperative would cause line loss to be reduced by, unaccounted for line loss to be reduced by anywhere from 2 to 4%. And I say, I know exactly why that is, because they've got metering problems that are taken care of with the deployment of the AMR, AMI device. And those metering problems could be taken care of without that. But the savings and 2 to 4% unaccounted for line loss in an electric utility is enormous. And if they could take those savings apart from the AMR, AMR device and implement them, the savings to the utility is incredible. The wiring for an electric meter is somewhat complicated for the average guy to understand, and many of the people who are doing the wiring are not as trained as they should be, and they tend to not follow diagrams, connection diagrams, as they should, and they kind of make things up as they go along, and they make mistakes, and unfortunately they don't recognize the mistakes, and since there's no, particularly on a new installation, there's no billing history. If they make a mistake, many times the consumer doesn't complain because the bill is less than it actually should be. Obviously, if the errors are taking place on a utility's larger loads, 1 or 2 errors on a big load as a percentage of the total utility load can greatly affect the financial health of the utility. We've actually seen municipal utilities and some cooperatives that got in financial trouble because of metering mistakes or errors or malfunctions. Many utilities have had the attitude that, particularly with the advent of the wide voltage range electronic meters, that they no longer needed voltage transformers because the meter can handle the 480 volts. The problem is that you create a safety issue when you have meter personnel that are around and adjacent to the 480 volt power that's available in the socket. And if they make a mistake, they get careless, they drop a screwdriver, a wire gets out of control, they get a flash, and you end up somebody with a burn. And it doesn't need to occur every day, but one burn can offset any savings by not using voltage reduction transformers or VTs. What makes 480 volt metering so dangerous is the fact that there's a misconception out there that usually in transformer rated metering installations particularly, you may have number 14 or number 12 copper wire feeding the voltage circuits in the meter. And many linemen and meter people look at this as not being very dangerous because, after all, it's only number 12 wire. And when they're used to dealing with 4/0 copper and large conductors that can carry huge amounts of current, they don't give it the respect that they should. And the problem is that a burn can occur very, very quickly in a 480 volt environment because of the arc that's established. They don't understand that for a few cycles, even a piece of number 14 wire can carry several thousand amps. And a few cycles is certainly long enough for an arc to be established and great damage to an individual done. Serious burns can occur in just a few cycles. And so therefore they don't give it the respect that they should. And if it occurs, you can get a person who can be laid up for some time because of a very serious burn and something that looked quite innocent. When you reduce the voltage down from 480 volts or 277 volts down to 120 volts or something similar, you reduce the amount of volatility in the surface. Components tend to last a lot longer if they're in that voltage range instead of the higher voltage. And it certainly is safer for the people that are working on it. It's quite difficult to wire one up incorrectly where it'll bill more than it should. It can be done. There are mistakes like that, but normally you make a mistake, the billing is less than it should be. And sometimes it can go on for many, many years.